this video, we'll be looking at one of the most important, but also one of the most tedious operations in pressure distribution system design, and that is pump selection. If you've ever designed a pressure dose drain field and had to rifle through pages of pump curves to find the pump that most closely fit the system, you know exactly what I'm talking about. Squirt provides an automatic pump selection feature that's unlike anything that's out there right now, and I'd like to take a few minutes here and show you how this works. What I've done is defined a simple system. On the screen here you can see we've got 0.156 inch diameter orifices, 5 laterals, 5-foot orifice spacing, and you can see that the laterals are not all the same length. There are some differences, and the diameter of the laterals are different. Also, if you take a look at the manifold sections, you can see that they're not constant spacing, so for whatever reason the laterals are all not the same uniform spacing, and there are different diameters in there as well. So what we've got now is a system defined. We've got you can see a 112-foot 2-inch diameter force main. We've got some fittings in there. So now we can go ahead and solve this system by clicking on the tabulated results button up here at the top. And there are the results for the system. Squirt has just solved all those laterals, put them into a complete distribution system, and presented the results. You can see that we've got an orifice flow differential anywhere 1.02, 1.85, and it varies, and that's because the diameter and length of the laterals vary. Overall, we have a flow differential across the system of 6.63%. So this system works. Now the next thing to do is to select pumps for the system. We can generate a system curve very quickly. This is something that very nice feature. Squirt, with just a click of the button, we generate a system curve showing the relationship between the flow rate and the total dynamic head. And this is where we need to be looking now to the pump curve to decide which pump fits this system curve the best way possible. So if we close out of this, so what we need to do is add pumps to this system and plot those pumps. Well, Squirt has a feature called an automatic pump selection, and if we go up here to the automatic pump select button and click it, what you see happening is that a number of pumps have been added to the pumps to be plotted list box over here on the side. There's a whole bunch of them that have been put in there, and these pumps all meet the user-specified criteria in the options window, and I'll show you what that looks like in a second. Now we can plot all those pumps by going to the Plot Pump and System Curve button. We click it, and just that fast, Squirt goes through and it plots all the pumps in the pumps to be plotted window and the system curve. The system curve is down here in black. System curve only goes up this far to about 40 gallons a minute. And the reason is our residual pressure is specified at a maximum of 10 feet. If we were to increase that residual pressure, we would see this curve continue up further into these pump curves. But what Squirt provides for you now is the intersection point up here. So for instance, this Grundfos AP12, which is this one right here, it provides the total dynamic head, the flow rate at the intersection point, and the residual pressure. So it back solves. The program has back solved to tell you what the squirt would be essentially if you were to use this pump. You'd be looking at about 3.9 feet of squirt. And it's done that for every pump in the pumps to be plotted window. But we've got too many pumps here to deal with. What we need to do now is refine this list a little bit. So here's how we do it. Close out of that. Go to Project. Project Options. Options window comes up. Click on the Pump Selection tab. Pump Search Options. Now, when Squirt completed its search for pumps, it was using the default search tolerance. And we'll explain a little bit later what the default search tolerance is. But because we want to refine the search, we don't want to see all those pumps, let's specify a search tolerance. So we'll specify a search tolerance. We've selected specify flow in gallons per minute. What this is saying is that we only want to see pumps that are within 3 gallons per minute of that particular pump's best efficiency point. Save out of there. Let's remove all those pumps from the list. Run a new automatic selection. And you can see that the list is pared down considerably, and that's because Squirt is going through selectively and only taking pumps that are within 3 gallons per minute now of the pump's defined best efficiency point. Now we can go back, replot, and here's what we see. We see 2 pumps now, and you see that these have the system curve strikes the pump curves very close to the center point of that curve. Let's increase our residual pressure. Let's go to 15 feet, and when we replot that, now we'll see that the system curve has been extended, and it intersects both pump curves. The red one here, the Chef 50, it's a hydromatic Chef 50. We can expect 10.8 feet of Squirt residual pressure, flow of 40.1 gallons per minute, and a total dynamic head of 39.8 feet. If we were to select the Myers ME75, we'd have 15.4 feet of Squirt, 48 gallons a minute, 48 feet of total dynamic head. So just that quickly, Squirt has calculated a system curve, plotted it with the pump curves, automatically selected pumps that meet the user's criteria, and backsolved for the residual pressure that you would expect to see. If we wanted to add another pump to that, just to see what it would look like, we could move over to the list, we could grab a pump, we could add it, and plot those. And now you see down here, here's the AP12, and while it's not a bad fit, certainly it doesn't hit the pump curve within 3 gallons per minute of the best efficiency point. Now let's take just a second and we'll see how those points are defined on the pump curve, the best efficiency point, for instance. You come over here to the number of the pump list box. You can click on any of these pumps, double click, and it will bring up the Add Pump to File window with the pump that you selected. Essentially, in order to add a pump to Squirt's pump file, you need to define these 5 points right here, these 5 points from the manufacturer's data. This point here and this point here, so these, not the end points, but the 2 inner points, define the limits of Squirt's default pump search routine. So, in other words, the default search will only show pumps where the system curve passes between these 2 points. And this is in the help file. You can see this described graphically in there. So, in other words, if a system curve passes to the left of this second point, Squirt will not show that as part of the default search. It has to, the system curve would have to pass between these 2 points. The center curve point here is defined as the best efficiency point. So when we said that we only wanted to see pumps that were within 3 gallons per minute of the best efficiency point, this is the point we're talking about. So the system curve would have to pass either to the right or to the left, but within 3 gallons per minute based on the definition that we set up in order for that pump to be included in the automatic selection. For additional information on entering pump curve data, and also for a more detailed discussion about how Squirt uses the entered data points, please refer to the section in the online help titled How Squirt Uses Pump Coordinates. And that'll conclude this video. Thank you.